Okay, so we want to graph parametric equations in the form like x equals 4 cosine t and y equals 6 sine t. The way we're going to do this algebraically is we're going to begin by squaring both sides. So I'll get x squared equals 16 cosine squared t. Y squared is equal to 36 sine squared t. Now I'm going to divide by 16. I'll get x squared over 16 equals cosine squared t, and y squared over 36 is equal to sine squared t. But wait a minute, we have a Pythagorean identity that says cosine squared t plus sine squared t equals 1. I'll write that down. Cosine squared t plus sine squared t is equal to 1. So using substitution, I will get x squared over 16 plus y squared over 36 is equal to 1. Clearly, that's an ellipse whose center is 0, 0. It has a vertical major axis 6 away from the center, which means its major axis is going to be 12 units long. And we can work that out pretty easily. Now I've got x equals 6 cosine t, y equals 6 sine t. And I want to do the same thing. X squared is equal to 36 cosine squared t. Y squared is equal to 36 sine squared t. Divide by 36. X squared over 36 is cosine squared t. Y squared over 36 is sine squared t. But in this case, my denominator is the same. It's not really an ellipse. It's actually a circle. Circles have a slightly different form. We'll multiply by 36. Oh, well, I guess we got to do the cosine squared t plus sine squared t equals 1. So we'll do the x squared over 36 plus y squared over 36 equals 1. But then I'm going to make it a circle by multiplying by the regular form of circle. X squared plus y squared equals 36. Circle whose center is the origin and whose radius is 6. Okay. You can see both of these, the ellipse and the circle, both had a center at the origin. How would you do one that doesn't have a center at the origin? Well, it took me forever to get used to using a smartboard. Now I'm kind of hate having to actually erase what you do, what you got to do. My microphone quit working, so I hope you can hear me, or else I have to do this whole thing all over again anyway. Well, let's try this. X equals 2 plus 4 cosine t. Y equals 3 plus 3 sine t. Notice my handwriting hasn't gotten any better. Okay, almost the exact same thing. I'm going to solve for the cosine of t. I'm going to subtract 2 and divide by 4. X minus 2 is equal to 4 cosine t. So x minus 2 over 4 is equal to cosine t. And y minus 3 over 3 is equal to sine t. Subtracted 3 divided by 3. Squaring both sides. X minus 2 squared over 16 is cosine squared t. Y minus 3 squared over 9 is equal to sine squared t. Just like before, cosine squared t plus sine squared t equals 1. Substituting, we'll get x minus 2 squared over 16 plus y minus 3 squared over 9 is equal to 1. This is an ellipse whose center is 2, 3, whose center is 2, 3, whose 4 units away from the center in the x direction, and 3 units away from the center in the y direction, square root and square root. If you follow this pattern doing a lot of these, you'll find out that you actually don't need to do the algebra to figure out what the conic is. If I have parametric equations, x equals h plus a cosine t, and y is equal to k plus b sine t, I will end up with x minus h squared over a squared plus y minus k squared over b squared is equal to 1. I'll have an ellipse as long as a and b are different. I will have an ellipse whose center is hk, moving out a in the horizontal direction and b in the vertical direction. Only difference is if a and b are the same, I have a circle. I'll take these denominators, multiply through, and I'll have it on the other side. That will be my r squared.